9.3 Day 3 Notes, Graphing Quadratic Functions. By the end of this lesson, you will be able to graph a parabola using the vertex, axis of symmetry, and table of values. To graph a parabola by hand, first you need to find the axis of symmetry. Second, we will find the vertex. Third, we will make a table of values. And last, we will plot the points and connect them to draw our parabola. So let's get started with example number 1. In our first example, y equals x squared minus 2x minus 3, first we want to identify a, b, and c. Our a value is 1. Remember that our a value is the number that is in front of our x squared. Our b value is negative 2. Remember that is the value that is in front of your x coordinate, your x term, and that our c value is our number without a variable, in this case negative 3. Right, remember that our graph opens up if our a value is positive, and our y-intercept is our c value, so in this case 0, negative 3. Alright, so let's get started in finding the axis of symmetry. We are going to use the formula x equals the opposite of b over 2a. Well, if I know that b is negative 2, then the opposite of b is positive 2. Over 2 times a, which in this case is 1. I'm going to go ahead and simplify this expression. 2 over 2 times 1, which is 2, equals 1. So my axis of symmetry is x equals 1. Alright, now that I have found my axis of symmetry, I know that that is the x-coordinate of my vertex. I'm going to take that and plug it into my function, so I need to rewrite my function. Let me just scroll up so I can see it. Where is it? There it is. So my function is y equals x squared minus 2x minus 3. And I'm going to plug in my x-coordinate, where x is, to find y. So y equals, and I'm going to go ahead and leave blanks where the x's are so that we know that's where we're plugging in our x-coordinate. Again, we said that the x-coordinate is 1, so that's what I'm going to plug in as a 1. And we're going to go ahead and evaluate this expression. 1 squared is 1, minus 2 times 1, which is 2, minus 3. 1 minus 2 is negative 1, minus 3, which is negative 4. So when x is 1, y is negative 4. Alright, we've now found our axis of symmetry and our vertex. Now we're going to move on to finding values for our table. Alright, in the center of our table we're going to put our vertex. Our x-coordinate was 1 and our y-coordinate is negative 4, which gives us an ordered pair of 1, negative 4. You want to pick values larger and smaller than your x-coordinate. Since here my vertex x is 1, I'm going to go ahead and pick 2, 3, and then I'm going to go the opposite way. I'm going to go smaller and pick 0, negative 1. So those are the values that I'm going to plug into the function to find y. Alright, so let's go ahead and get started. The first value I'm plugging in is negative 1. So I'm going to go ahead and plug that in. And when I do that, you know what, let me go ahead and make my pen just a little bit smaller. Alright, so negative 1 squared is 1. Negative 2 times negative 1 is positive 2, minus 3. 1 plus 2 is 3, minus 3, which is 0. So when we plugged in negative 1, we got 0. So our ordered pair is negative 1, 0. Alright, let's go ahead and plug in the second value, which is 0. 0 squared is 0. 2 times 0 is 0, minus 3. 0 minus 3 is negative 3. So when we plugged in 0, we got negative 3. So our ordered pair here is 0, negative 3. Now I'm going to go ahead and plug in 2. 2 squared is 4, minus 2 times 2, which is 4, minus 3. 4 minus 4 is 0. Minus 3 is negative 3. So when we plugged in 2, we got negative 3. So our ordered pair is 2, negative 3. Now we're going to plug in our last value, which is 3. So 3 squared is 9, minus 6, minus 3. 9 minus 6 is 3 minus 3, which is 0. So we're going to plug in 0. So our ordered pair here is 3, 0. All right, now we have enough ordered pairs to plot and graph our parabola. So I'm going to scroll up, and actually, you know what, I'm not going to be able to see all my points, so I'm going to have to scroll back and forth. So the first point I'm going to plot is negative 1, 0. So I'm going to go up here, and we're going to plot negative 1, 0. That's right here. All right, my next ordered pair that I'm plotting is 0, negative 3. So 0 left and right, and down 3. My next ordered pair that I'm plotting happens to be the vertex, which is 1, negative 4. So now I'm going to go right 1, down 4. I'm going to continue going through my table. The next ordered pair we're going to graph is 2, negative 3. So we're going to go from our origin, right 2, down 3. And our last ordered pair we're graphing is 3, 0. So I'm going to go right 3 and up and down 0. So notice if I connect these points, I have my parabola. Now that is all there is to graphing a parabola by hand. Let's go ahead and try example number 2. Alright, first thing we want to do is find A, B, and C. A is 1, B is negative 4, and C is negative 3. Our graph is going to open up because our A value is positive, and our y-intercept here is 0, negative 3. Alright, first thing we have to do is find our axis of symmetry. Remember, the formula for our axis of symmetry is that x equals the opposite of b over 2a. So if my b value is negative 4, the opposite of that is positive 4 over 2 times my a value. If I simplify this, I get 4 over 2, which simplifies to 2. So my axis of symmetry is x equals 2. Now that I have found my axis of symmetry, I know that that value is my x-coordinate of my vertex. I'm going to take that value and I'm going to plug it into my function everywhere that there is an x. So I'm going to get that y equals 2 squared minus 4 times 2 minus 3. And I'm going to evaluate that. 2 squared is 4. Minus 4 times 2, which is 8, minus 3. 4 minus 8 is negative 4. Minus 3 is negative 7. So my vertex is 2, negative 7. The next thing I'm going to do is put my vertex into my table. Remember, the vertex goes in the middle, 2, negative 7. We want to find values bigger and smaller than our x. Since my x-coordinate is 2, we're going to pick 3, 4, and we're going to pick 1, 0. Now that we've done that, we're going to go ahead and plug in each of those into our function to find their y-coordinate. So for 0, we're plugging in 0. So y equals 0 squared minus 4 times 0 minus 3. So that's 0 minus 0 minus 3. 0 minus 3 is negative 3. So our ordered pair is 0, negative 3. Alright, next we're going to plug in 1. So I'm going to go ahead and just erase this so we can just repeat it. Alright, so we've got y equals 1 squared minus 4 times 1 minus 3. 1 squared is 1, minus 4, minus 3. 1 minus 4 is negative 3, minus 3 is negative 9. So we're going to plug in negative 9. Alright, now we're going to plug in 3. So y equals 3 squared minus 4 times 3 minus 3. 3 squared is 9 minus 12 minus 3. 9 minus 12 is negative 3 minus 3, which is negative 6. Ooh, and you know what? I just realized that actually I made a mistake over here. This should be negative 6 also. So let's fix that, negative 6. Let's fix that up here and here. So that should be negative 6 and negative 6. Alright, so here we've got negative 6. Okay, let's keep going. So the ordered pair is 3, negative 6. Alright, last we're going to plug in 4. So we get y equals 4 squared minus 4 times 4 minus 3. 4 squared is 16, minus 4 times 4, which is 16, minus 3. 16 minus 16 is 0, minus 3 is negative 3. So we plug in negative 3, and our ordered pair is 4, negative 3. Now we can go ahead and plot each of these ordered pairs. Our first one is 0, negative 3. Our second ordered pair is 1, negative 6. Our next ordered pair, which is our vertex, is 2, negative 7, followed by 3, negative 6, and last 4, negative 3. Now you have enough points where you can graph your parabola. Alright, let's go ahead and do the next example. First, let's find A, B, and C. So in this case, A is negative 1, B is negative 2, and C is 3. Here, our parabola is going to open down because A is negative, and our y-intercept is 0, 3. To find our axis of symmetry, we're going to use the formula x equals the opposite of B over 2 times A. The opposite of B in this case is positive 2 over 2 times negative 1. We're going to get 2 divided by negative 2, which is negative 1. So our axis of symmetry is x equals negative 1. Once we have that, we know that that is the x coordinate of our vertex, so we'll plug that in. We're going to use that value in our function. So here you have to be careful because it's a negative x squared and negative, and our x is negative 1. You have to be careful when you plug that in. Minus 2 times negative 1 plus 3. So order of operations tells us that we have to do negative 1 squared first. That's this part. So we get negative times positive 1, because negative 1 squared is 1. Negative 2 times negative 1 turns into a positive 2 plus 3. This turns into negative 1 plus 2 plus 3, which is 1 plus 3, which is 4. So our vertex is negative 1, 4. So let's go ahead and put that into our table. Negative 1, 4. So I'm going to pick numbers bigger and smaller, so negative 1, 0, 1, and negative 2, and negative 3. We're going to plug those in and figure out what our y-coordinates are. So again, we have y equals negative x squared minus 2 times x plus 3. So in this case, I'm going to start by plugging in negative 3. So negative 3. When I do that, we get, again, square the negative first. So that turns into a negative 9 plus 6 plus 3. Negative 9 plus 6 is negative 3 plus 3, which is 0. Now we're going to go ahead and plug in negative 2. So I'm just going to do a little bit of erasing here. Alright, and let's go ahead and plug in negative 2. Alright, so first we've got to do negative 2 squared, which is 4. Negative 2 times negative 2 is positive 4 plus 3. This is 0 plus 3, which is 3. Now we're going to go ahead and plug in 0. So again, I'm just going to erase what we've done so that I don't have to move our screen. Alright, and we're going to plug in 0. So here we go. So 0 squared is 0. 2 times 0 is 0 plus 3. We get 0 plus 3, which is 3. And then last we're going to plug in 1. So again, let me just erase what we've done. And now we're going to plug in 1. So 1, 1. 1 squared is 1, minus 2 plus 3. 1 minus 2 is negative 1 plus 3, which is 2. Oh, is that right? Did I make a mistake? Let's see. I'm not sure, but I think 1 minus 2 is negative 1 plus 3 is 2. I think I made a mistake. Where's my mistake? Maybe I made it when I plugged in negative 3. Now the reason that I'm noticing I may have made a mistake is because the values over here should match our values over here. And notice that here I have a 2 and here I have a 0. I'm going to go ahead and plug in the negative 3 again and check and make sure that I did that correctly. Alright, so negative 3, negative 3. Alright, negative 3 squared is negative 9 plus 6 plus 3, that's negative 3 plus 3, which is 0. Okay, well, let me go ahead and check our 1 just one more time because I think now I know what I may have done. Alright, let's check. I'm plugging in 1 again. 1 and 1. 1 squared is 1 minus 2 plus 3. So what I forgot to do is make this negative. Negative 1 minus 2 is negative 3 plus 3 is 0. So I know there was my mistake. This should be a 0. Alright, now that I've got my ordered pairs, I'm going to go ahead and plot. So my first ordered pair is negative 3, 0. So negative 1, 2, 3, 0. My next one is negative 2, 3. Negative 2 up 3, 1, 2, 3. My vertex is negative 1, 4. Negative 1, 4. Next ordered pair is 0, 3. And my last ordered pair is 1, 0. So I can connect my points and I have my parabola. Alright, last example. Go ahead and try this example on your own. When you're finished, check it with Mrs. Wilkin or Mrs. Stahl, and then you can move on to your homework.